So just like we had the definition of a vertical asymptote, we can now formally define horizontal asymptotes. You had seen vertical asymptotes and horizontal asymptotes in a college algebra course, but you were not able to see the mathematical definition of these vertical and horizontal asymptotes. So what is the formal definition of a horizontal asymptote? Here it is. It says the line y equals L, and it's very, very important here. Again, you need y equals. This is a line, a dotted horizontal line, is a horizontal asymptote of a graph f when the limit as x approaches negative infinity of f of x equals L, or the limit as x approaches infinity of f of x equals L. So it doesn't matter if it's to the left or to the right. If it approaches a single y value to the left or to the right, that horizontal line is a horizontal asymptote. It says, note that from this definition, it follows that the graph of a function of x can have at most 2 horizontal asymptotes. So you can never have more than 2 horizontal asymptotes. You could have as many vertical asymptotes as you want, but you can only have 2 horizontal asymptotes because you have the left behavior and the right behavior. It says limits at infinity have the same properties as the limits discussed in section 2.3. For example, the limit of the sum is the sum of the limits, and the limit of the product is the product of the limits. Same thing right here, even with infinite limits. It says similar properties hold for negative infinity. They just showed the positive infinity. Same dang thing. Next one, 410, really important one here for us. It says if R is a positive rational number and C is any real number, then the limit as x approaches infinity of a constant over x to the r. Notice x to the r would be going to infinity or negative infinity. So the limit of a constant over infinity is 0, and the limit of a constant over negative infinity is 0. Doesn't matter if it goes to positive or negative infinity. Anytime you have a constant on top and positive or negative infinity on bottom, that always goes to 0. So that's what that one's saying right here, is a constant over infinity approaches 0, okay? And it says the second limit is only defined if x to the r is defined when x is less than 0. So all it's doing is worrying about your square roots. You can't take square roots of negative numbers types things, okay? So it just has to be defined. The next one gives you some good ones here. The limit as x approaches negative infinity of e to the x. If you remember what the graph of e to the x is, looks something like this. So as you go to the left, as you approach negative infinity, it approached 0. So that's one you should remember. And likewise, the limit as x approaches infinity of e to the negative x. If you remember what e to the negative x looks like, that would be something like this right here. That's e to the negative x. So as you go to the right, that approaches 0 as well, okay? So evaluate the following limits. These are infinite limits. Well, what's the limit as x goes to infinity of 5? That's just 5. What's the limit as x goes to infinity of 2 over x squared? Well, notice this would go towards infinity. So the entire thing would be a constant over infinity, which goes to 0. So this would be 5 minus 0, which is just 5. If you don't believe me and you're not comfortable with this, again, you could always do x and y being plugged into 5 minus 2 over x squared. And you could start off with the number, for instance, 1, then you can plug in 10, then you can plug in 100. And you could see what happens, and what you'll notice is as you go further and further, this is going to approach the y value of 5. So always, again, your fail-safe is using that chart, using that table function or table feature in your calculator, and I'm perfectly fine with that. Okay, let's look at B. It's the limit as x goes to infinity of 3 over e to the x. Well, if we think about e to the x, as x gets larger and larger, e to the x, sorry, let me use red, e to the x goes to infinity. So this is going to approach 3 over infinity. As you approach 3 over infinity, that approaches the value 0. So a constant over infinity always approaches the value 0. So again, this is me knowing what e to the x looks like, what happens to e to the x as I plug in larger and larger numbers. Again, your fail-safe, always plug it into that chart. Plug in like a 1, a 10, a 100. See what happens to your y values, and you're going to see they approach the value of 0. So please feel free to plug that into your table. Again, you're plugging it into 3 over e to the x when you plug it into the table. Plug in those values and see what you get.